The landing distance will also increase due to delayed nose wheel lowering or delayed flare. Immediately easing the nose wheel onto the runway reduces lift and places the airplane weight over the main gear, resulting in increased braking effectiveness. This is more effective than aerodynamic braking when the nose wheel is hauled off the runway. Delaying flare may increase the landing distance by 30% if a final approach speed is increased by 5%. Systems malfunction. You can check the Quick Reference Handbook for the increment in final approach speed and the associated increment of the required landing distance for system malfunctions affecting lift dumping or braking capability. Power on touchdown. Landing distances published in the AFM are predicted on the use of idle thrust. There is no allowance for forward thrust. Touchdown with power on may prevent ground spoiler deployment. Failed or late deployment of spoilers. Under the MEL, the aircraft cannot be dispatched with failed spoilers. The spoilers open on ground automatically when three conditions are met simultaneously. These conditions are weight on wheels as sensed by the main gears, wheel speed over 25 knots, and both thrust levers below idle position. Failure of the ground spoilers to deploy automatically should be called out. During hydroplaning, the wheels may not spin up, preventing the wheel rotation signal from being sent to the various aircraft systems, mainly spoilers and brakes. Late application of brakes or reverse. On the Embraer jets, brakes are available as soon as the main gear is on the ground. It is not necessary to wait for nose wheel touchdown to start braking. If the landing weight is limited by runway length, the use of maximum brake effort is mandatory until it becomes obvious that there is enough remaining runway for the use of milder braking. The main threat to stopping the aircraft is the lack of braking effectiveness. This depends on the level of braking and runway friction. Plan and use the required level of braking for the prevailing runway conditions. Commence braking at high speed, dissipating energy early. Safe braking is better than comfort braking. Wet runways have much lower friction levels than a dry runway. Friction depends on the runway surface, materials, and conditions. Runway contamination may reduce friction to a very low level. The FAA defines that a runway is contaminated whenever standing water, ice, snow, slush, frost in any form, heavy rubber, or other substances are present. Of course, runway friction also depends on the tire tread condition, inflation pressure, and type of runway surface. A layer of fluid between the tires and the runway reduces the contact area and creates the risk of hydroplaning. Hydroplaning occurs when the tire lifts off from the runway surface, effectively water skiing on the fluid layer. Hydroplaning results in a partial or total loss of contact and friction between the tire and runway, and in a corresponding reduction of friction coefficient. Main and nose wheels can be affected by hydroplaning. The degree of hydroplaning depends on the following factors: absence of runway surface roughness and inadequate drainage, that is, absence of transverse saw-cut grooves, depth and type of contaminant, tire inflation pressure, ground speed, and anti-skid operation. Hydroplaning may occur at touchdown, preventing the wheels from spinning up and from sending the wheel rotation signal to various aircraft systems. Conducting a firm touchdown can reduce hydroplaning. Landing distances are published in aircraft operating manuals, AOM and Quick Reference Handbook for dry runways, and runway conditions for various contaminant types. Never use the parking brakes if the aircraft has lost the friction with the runway. The use of the parking brakes inhibits the anti-skid and the deployment of the ground spoilers. Remember, if one engine is inoperative or the reverse is dispatched inoperative, as per a MAL provision, you should bring only one, the good engine thrust lever, to reverse during landing. The other must be kept at idle. Moving both thrust levers to reverse may result in no reverse thrust at all.